Now in this final problem on the intersecting chord and secant theorem, we're going to combine both theorems together in this quite difficult problem. Now let's just remind ourselves of the intersecting secant theorem. A secant is a line which cuts the circle, like this. And the intersecting secant theorem says that the length from this point outside the circle to the first point where the secant crosses the circle, so that length of A, if you multiply it by the length from this same point to the second point it crosses the circle, so where it exits the circle, so A times B will be the same as when we do it for the other secant. So this length of C to the first point it cuts the circle, times by, from this point, the length to the second point it cuts the circle, so C times D. So we get that equation there. So let's apply it to here. We've got, from P, we've got this secant here and this secant here. Now we don't know these lengths inside the circle, so I'm just going to make them R. I notice there's an X down there at the bottom, so I can't reuse the X. So these are both R for the radius. This would be the radius here as well. So now let's just apply the theorem. From this point here, P, we do the length from here to the first point it cuts the circle, so that is 9. Let's do it at the bottom, 9. Times by, and then the length to the second point it cuts the circle. So from the starting point again of P, all the way up to the second point it cuts the circle. So that's 9 plus R, that's 9 plus 2R. So it's times by 9 plus 2R. That is equal to, if you, again, all the length should be from this starting point P. It's the 11, so it's 11 times by, and then again from that starting point, 11 plus 7 plus 9 to the second point it cuts the circle, that is 27, isn't it? So you get that. Now 11 times 27 is 297. And then expand the bracket out, you get 81 plus 18R. If we subtract 81 from both sides, I get 216. And then if you divide both sides by 18, you get 12. So R is 12. So that's great. I can put the 12 in here now. So 12, that's 12, that's 12. These are all the radius of the circle. And also actually you can come up with an expression for this length here from O to Y, because this is the radius here, that is 12, and that's X. So if I subtract them, I get 12 minus X there. So let's put that here. Now we're going to use the intersecting chord theorem. Can you see that this chord here, a chord is a line that connects 2 points of the circumference of a circle, that intersects this chord here, right? And the point of intersection is this point Y here, right? So the intersecting chord theorem states that if we do the lengths either side of this point of intersection of one chord, so this length times by this length is equal to the product for the other one. So this length of 9 times by this length of 7. So let's come up with an equation for that. Let's first do the easy one. So 9 times 7, that product. So 9 times 7 is equal to, and let's consider for the other line, where we've got this length to this point times by this length on the other side of the point of intersection. So we've got this X times by that length. Now that length here is 12 plus 12 minus X, which is 24 minus X. So it's X multiplied by 24 minus X. So let's do that. Let's simplify. So 9 times 7 is 63. Multiply out the bracket, 24x minus x squared. Let's put it all on the side where x squared is positive. So you've got x squared minus 24x plus 63 equals 0. Now we need to factorize that. We need two numbers which add to give minus 24 and times to give 63. Well, I think that's minus 21 and minus 3. So we get x minus 21, x minus 3 is the factorization. And then if the product of two things is equal to 0, then either this is 0 or this is 0. So if x minus 21 is 0, x will be 21, or x will be 3 from the other bracket. Now, which one is it? Because I bet you that one of these is not a valid length. Can x be 21? Well, no, x can't be 21, because if that was the case, you'd have 12 minus x, 12 minus 21 would be a negative length. So that's bad. So it must be that x is equal to 3. X could be 3. And that is the final answer. X is equal to 3 centimeters.